and welcome to the Wonders of the Lithosphere. I'm here with today's special guest, Brian Cox, everyone! Hi Brian.
Hello.
Brian is here to talk to us about rock salt, otherwise known as sodium chloride. So Brian, what can you tell us about rock salt?
I'd just like to start off by saying that rock salt is very, very interesting. It starts off like this. This can represent the nucleus, and these can resemble the electrons. And what they do is they go around and around and around, and they give away a few
Brian.
to this, the atom of the chloride. Yes, you see, this was sodium, and it all works like that.
I think you've got too many electrons. I think there's meant to be about
You're wrong.
That. I think.
You're wrong.
No, I'm pretty sure there's not.
Anyway, I think we should be telling our viewers more about the uses of rock salt.
Of course, Brian. Well, as you all know, rock salt is used in cooking. It is also used to melt ice cream, and it is used to melt ice on roads on cold days.
You're right.
Yes, I am.
Anyway, we'll see you next time. Special guest.
When our special guest will be Nigella Lawson.
Thank you very much. I'll see you later.
And welcome back once again to the Wonders of the Lithosphere. Today we are going to be talking about pumice with none other than Nigella Lawson. Hello Nigella.
Hello. Hello all you viewers. Very pleased to meet you all.
So Nigella, what can you tell us about pumice?
I make it no secret to show you all that I'm a complete airheaded tart, and I have no idea what this is. You want me to tell you what it's for?
Yes, please.
Oh, what they were saying, I think it's used to rub your foot, make it nice and smooth, like my bottom. It's also used in toothpaste and face cream. Wine.
And welcome back to the Wonders of the Lithosphere. Today's special guest is Severus Snape. Hello,
Good evening.
So, Severus is here to tell us about granite, a rock made from quartz and feldspar.
Ah, yes. Well, on many recorded occasions, granite has been used in potions. Crush it up and put it in a bit of polyjuice potion. Sends it right off. Also, there are many, many chemicals infused within the rock. For example, silicon dioxide, aluminium oxide, potassium oxide, sodium oxide, calcium oxide, iron oxide, etc. etc.
So, from that I can gather that granite is a giant covalent crystal, so it must be incredibly strong. But you mentioned that it contains
I must correct you there.
silicon dioxide.
I believe it's ionic.
Why did you write down covalent?
I didn't. The script was written by Brian Cox.
I see. We'll just have to change that. Are you sure it's ionic?
I'm sure.
So, Severus, what I can understand from that is granite is a giant ionic crystal. It's incredibly strong. Now, you mentioned that it contains silicon dioxide, and that is one of my favourite chemicals. Can you tell us a little bit more about it?
Well, I believe that is an occasion for another day. Maybe Mrs Calvert can tell us more.
Okay, if you want to tell us more, then I'll just mention it. Hello, and welcome back to the Wonders of the Lithosphere. Today's special guest is Mrs Calvert.
Hello, everyone. Thank you.
Mrs Calvert, I'm going to have to ask you to pop these on.
Of course, dear.
Is that alright?
Yes.
Yeah. So, Mrs Calvert is here to talk to us about silicon dioxide. What can you tell us about that?
Well, silicon dioxide is found within many rocks in the lithosphere. Don't you know?
What is its electronic structure?
Well, as you can see here, it has lots of electrons.
So what's in silicon dioxide?
Well, in silicon dioxide there is silicon
Yes.
and oxygen.
Now what's special about these two elements?
Well, they have lots of electrons on them.
Why do they combine to create silicon dioxide?
Well, as you can see, they obviously use covalent bonding. Yeah. Brilliant.
So as you can see from the diagram, the oxygen molecules join up with the two silicon electrons to create 8 around the oxygen's outer shell and 8 around the silicon's outer shell.
Well done.
What else can you tell us about silicon dioxide, Mrs Calvert? What is it found in, for example?
Granite.
Ah yes. Etc. Etc. So, thank you very much, Mrs Calvert, for your interesting insight to silicon dioxide. Next week, I will be talking to Mr Hunt about another chemical in the lithosphere. Thank you, and goodbye. Goodbye from Mrs.
Bye, Mrs Calvert.
And
goodbye.
Bye-bye. Hello, and welcome back to the wonders of the lithosphere. Today's special guest is Mr Hunt. Hello, Mr Hunt. I'm going to have to ask you to pop these on. So, Mr Hunt is here to talk to us about gold.
Yes, gold.
What can you tell us about gold then?
Well, its chemical symbol is AU. It's very metallic. It's a precious metal. It's used in jewellery. It's used in... you mine it normally. It's forged by pushing atoms together very tightly until they form a refined chemical called gold. It has 79 electrons in it, which means it has 79 protons.
So, Jake, what does gold look like?
Well, it's a sort of yellowy, browny, shiny metal.
What sort of things are made of gold?
Well, jewellery, decorative objects, precious items that you give to someone.
I see. Could we maybe see a diagram of just how many electrons and outer shells it has?
Well, here's one I made earlier. It's very good. I did it
I
myself.
see, yes.
Yes.
You did it.
Yes, I did it.
So thank you very much, Mr Hunt. Hello, and welcome back to the wonders of the lithosphere. Today's special guest, Mrs Bayliss.
Hi! Right, number groups. Sorry, right, carry on.
Mrs Bayliss, I'm going to have to ask you to pop these on.
Of course. My daughter wears glasses, did you know?
Does she?
Yes.
So, I hear you're here to talk to us about coal.
I am.
What can you tell us about it?
Well, coal is made up of carbon and a little bit of sulphur.
I see.
Right. And coal you use all the time, like on fires as a fuel.
Yes.
And this is the format of coal.
Well, thank you, Mrs Bayliss, for that.
That's okay.
This, unfortunately, is the end of our lithosphere programme.
Did I tell you about